platform. Animals, insects produce chitin, and fungi produce cellulose and chitin. So what does that mean? Let's have a look at it. This is a slightly skewed one now, because now all the bacteria have been squashed down here. So now we've got fungi, animal, plants, and we are just, we are somewhere there. So we expand that, look at this, and we expand it again, and then again, and then finally here we are, Homo sapiens in the middle, and the one above us is mice, and one above that is the rat, and the animal immediately below that is what they call rubber eels, which is a form of amphibian. So they're all, according to this picture, all these animals are very, very closely related.
Where did you get that diagram? What did you make?
Somewhere on the internet.
It was originally in Proceedings of the National Academy of Sciences. I forgot the name of the article, but I think it's possible to dig up.
Okay.
I mean, there are loads of these. They've become very popular the last couple of years.
Will the different ones end up with different animals next to us, or do they all have mice next to us?
You could have arranged it so different ones would be right next to us, but it wouldn't have made much difference in the overall scheme of things. I mean, for instance, here you can just see they put you could have put this blade, so it could have gone around the other side. So in fact, here we've got mammals, reptiles are up here, and we've got amphibians down here. Now you could have switched that around. We could have been at the far end of the reptiles, but it wouldn't make much difference. So here's my conclusion, is that a Martian or a silicon-based life form would basically look at a human and look at a rodent and think they're almost identical. If it didn't know what a cell was, if it wasn't made of cells, it would think, well, they are basically the same thing. They've got these funny things called cells, they've all got Golgi bodies and ERs and nuclei and chromosomes. All that's different is the way the cells coordinate together. And if aging is a subcellular process, which I think it mostly is, it won't make any difference to how we age. So going back to the photo.
Can I just ask you, because you highlighted there, our closest to say rodents.
Yes.
What do you think the blind African mole rat is can tell?
Well, that would be about the same as the rodents. We diverged from rodents about 100 million years ago. And I think a mole rat, well, that's a rodent as well. So it would have probably the same common ancestor that we have with a mole rat that we have with.
Well, I think it's really interesting the African mole rat because compared to its cousins, it's very rapidly kind of evolved and has lived a long time, hasn't it? Like multiple.
Yeah, I mean, they live in social groups. And essentially, you have like queen mole rats, don't you, and workers, and the queens themselves live a very. I think the workers live a long time as well.
Well, they would if they were predated. So they would if they were predated.
Are mole rats heavily predated?
I think the workers are. Yeah, because the thing is that the queen can live 20 years or something like this, but
I thought
the worker only lives three or 4 years.
Really? Oh, it wasn't like that. I thought the workers lived a relatively long time as well.
I think they're in captivity. They probably would.
All right. Yeah. But they're definitely rodents, so they would be the same. They would be we'd share the same kinship with them as we do with other rodents.
Sorry. Couldn't we, in addition to focusing on the genetic similarities between mice, rodents in general, and humans, couldn't we compare those studies conducted on rodents that were then conducted on humans as well, and see what proportion of them, what results that were observed in rodents were also observed in humans when they were tested in humans, and that seems to be a very good way of.
Yes, we could, but unfortunately there are very few comparative studies like that.
I don't mean just on supplements. I mean generally.
Well, generally you can, but what you have to measure in humans is like how it affects their health. you can't really measure how it affects their lifespan. And in animals, you can measure the lifespan more easily. But it's sort of harder to measure the effects on their health. You tend to sort of kill the animals and dissect them to see what's happened. But you can compare them. I mean, a bit later on we'll see a couple of slides where I try to do some sort of comparison. So we found so far folate increases lifespan, mean values, decreases the risk of Alzheimer's, seems to protect us against DNA damage, of some forms at least. But the point is, there's nothing unique about folate, it's just one coenzyme amongst many. So the question is, what happens if we look at the other coenzymes? So coenzymes come in two sorts, so that we can either make them ourselves. This is the case of coenzyme Q10, which some people take for aging, and SAM, which we looked at earlier on to do with methylation, or that one shouldn't be in there, because that's one of the ones sourced from our diet. That's an error. So I was going to say coenzyme A is made from vitamin B5. Minerals also are cofactors, just like coenzymes are. Obviously, you can't have to get them from the diet because you can't make elements. And there are other vitamins that we know that we've tested. We found they also, in animal models, decrease cancer rates. And in humans, for vitamin D, niacin reduce ultraviolet induced skin cancer in rats, mice, I think it was. Thiamine has also reduced cancer rates. And even in humans, we now think vitamin D has reduced cancer. And there was a trial where they gave people 1,100 IU of vitamin D against the RDA of about 400, 200, depending on your age.
I was told that vitamin D was poisonous in excess.
It is, but what's the excess level?
Right.
In this particular trial, I gave them 1,100, and they found that after the initial year, cancer rates went down by about I think 70%. Now, a human normally, if you need ultraviolet light to make vitamin D. If you expose someone to ultraviolet light completely, you find they produce about 10,000 IU before the feedback mechanisms shut down and stop you producing any more. So I would think it very unlikely that anything less than 10,000 is going to be poisonous. And in fact, I think toxicity only really kicks in about 30,000 IU a day. But you can also take vitamin K to protect. I think if you take a lot of vitamin D, you can get various calcium imbalances happen. But if you take vitamin K as well, that will normalise that.
Do we have some kind of restriction on vitamin D cells? Because whenever I've been in the health shop, I've looked for it. I can only ever find it in combination with something else. You know, vitamin D plus calcium.
I don't know.
Some kind of multi-form.
I get my vitamin D from America, so perhaps that doesn't. Perhaps those restrictions don't apply.
I just wondered if there was a restriction, because whenever I looked at the health shop, I'm not able to find that. Just vitamin D.
What does it tend to come with?
How do you?
Now here's an attempt to compare different animals and what happens with lifespan when you give them the various B vitamins and a few other things. So the first column is what happens when you give it to fruit flies. And the point here, it's not the absolute numbers. There's 2 points from this mainly. One is that as you look from fruit flies to rodents, you see the percentage increase is roughly the same. So that's another indication that our aging, they are good models for aging. And the other thing is that coenzymes didn't increase maximum lifespan. It was the minerals that increased maximum lifespan. And also, these are additives. So this is all based on one experiment. These particular ones, the references in the corner determined, well, those are just because I copied from my own document. But we see the combination experiments here, where someone gave different combinations of B vitamins and RNA. They were all done back in about 1948, 1949. And as far as I know, no one's ever tried to duplicate